Biomechanics is the field of science that studies how the laws of mechanics relate to movement. The success of the chosen specialized movement sequence, being a volleyball serve, is hindered by the understanding of biomechanical principles and functional anatomy. Functional anatomy is a field of science that studies how the muscles and bones in the body work together to produce movement. This knowledge has helped me develop and apply strategies to better my volleyball serve. We study biomechanics to identify better, more effective techniques, correct technical errors, reduce injury, and to understand the importance of equipment design. The most significant biomechanical deficiencies in my serve is stability and summation of forces. Stability in sport is defined as the ability of an individual to control the influence of internal and external forces on their performance of a modal skill. Contributing to the lack of stability is the location of my center of gravity. Center of gravity can be defined as the point in an object where its weight is balanced. As seen in this image, my center of gravity is to the left as I've had to lean to make contact with the ball. This could be an inconsistency in my ball toss or a way of reaching my maximum stretch. Either way, it is affecting my stability, not only in the air but also when I land. This has significant impact on the rest of the point as it will require a greater amount of time to get myself in the position and ready to have the ball returned. As seen in the professional serve, the center of gravity is closer to the middle of his body, but he is still reaching his maximum stretch. The goal of maximum stretch is to complete specific movement strategies like placement or power. To increase the biomechanical correctness, a strategy has been put in place. This is to focus on moving my ball toss closer to the center or even to the right of my body. As a result of this, I will be able to keep a more upright posture and ultimately closer replicate the phase of the serve. Another aspect of my serve contributing to my instability is my base of support. Base of support is the area a person or thing that is in contact with the supporting surface. In the case of my volleyball serve, my base of support when taking off for my jump is smaller than compared to the professionals. As proven in Source 1, the stability of a serve is hindered when trying different serving positions. As seen in the source, the beam position, having one leg behind the other, dramatically reduces my base of support. As a result of this, my stability was decreased, which resulted in further biomechanical weakness. A solution to this weakness is paying closer attention to my form when doing my run-up and pre-serve routine. Having a wider stance as well as having one foot in front of the other will increase the stability before I jump as seen on screen. These modifications have provided significant increase in the biomechanical correctness of my serve, and this is evident through the increase of stability when landing and the more upright form during the serve. Although there is a significant limitation in the success of these modifications. The ball toss is a highly important yet inconsistent movement strategy, and is hard to practice and to consistently repeat. Another important biomechanical aspect of the volleyball float serve is summation of forces. Summation of force can be defined as the sequential combination of forces produced by different parts of the human body acting together to maximize force production. As well as this, the musculoskeletal system and joints have an important role in the success of a serve. As seen in the professional's float serve, summation of forces is evident through the full process of the serve. As seen in the transition from linear to angular motion in this particular phase of the professional serve, significant movement in the hinge joint of the knee and also in rotation of the ball and socket joint in the hip combine to summate the appropriate amount of force. Contribute to this are the primary movers that power this movement, including the rectus femoris, the vastus lateralis, and the gluteus maximus. My serve at the beginning of the unit lacked biomechanically correct summation of forces and sufficient use of agonist muscles. This is evident in my transition from forward motion into upward motion. I failed to use my arms and legs effectively to change the direction of motion and use the best technique to maximize force summation. Considering the lack of force summation is through the process of jumping, I decided to incorporate a four-step approach into my serve. A correct four-step approach includes, for a right-hand player, a step with right foot, then a step with left foot, and then finally the plant, steps 3 and 4, to perform the jump. Steps 3 and 4 should be placed about shoulder width apart to form a tight spring. The spring combined with the powerful hip extension and arm action will lift you up. This will help me to better replicate the professional's technique and ultimately increase the effectiveness and efficiency of my force summation. After further analysis, it is evident that the application of a four-step approach is effective in increasing the summation of forces through the increase of speed. A limitation to this applied strategy is the extra amount of room required to perform this run-up. Not all chords have the same amount of room behind the baseline, leading to a new inconsistency. Projectile motion is a term used to describe the movement of any object that has been launched, hurled, or thrown into the air. As soon as any object is released into the air, it is referred to as a projectile. The incorporation of the four-step approach has enabled me to decrease the release angle and create a more downward projectile motion through the increase in jump height. The effectiveness of the movement strategy of placement is increased through the decreased angle of the projectile motion, enabling a short placement of the ball. The understanding of functional anatomy and more specifically biomechanical principles has helped to identify biomechanical weaknesses in my serve. This has resulted in the formation of strategies to increase the effectiveness and efficiency of my serve.